Hi, hello, namaskara. Good morning, my dear students. So, again, welcome back to my YouTube channel. So, today we are discussing one more important topic for 3 marks, which will be asked in your examination for 3 marks, that is vector algebra. So, this is very, very important because the questions will be asked on this chapter on 3 marks, 2 marks, as well as 1 mark also. So, today we'll start with some of the basic definitions and the operations and the properties of the vector algebra along with the 3 marks important questions. Okay, and I hope you're all preparing well for your examinations, and today we'll discuss some of the very, very important examples on vector algebra which will be asked for 3 marks in your class 12 board examinations. Okay, let us see one of the important example on vector algebra. So the question is, if vector A, B and C are 3 unit vectors, name it is 3 vectors are unit vectors, such that vector A plus B plus C is equals to 0. And this is the given. Find the value of A dot B plus B dot C plus C dot A. Okay, this is what we need to find, and he has given 2 quantities. One is A plus B plus C is equals to 0, and these A, B, C are 3 unit vectors. So you should know what is the definition of the unit vector. So unit vector in the sense the modulus or a magnitude of any vector is equals to 1 or unity. Okay, if the modulus is 1, then we say it is a unit vector. Okay, so he has given A, B, C are unit vectors. First let us write down the given according to the statements. Let us say A, B, C are unit vectors in the sense magnitude of vector A is equals to 1, magnitude of vector B is equals to 1, and magnitude of vector C also is equals to 1 because of this first statement. Okay, and also he has given A plus B plus C is equals to 0. These are the quantities given in the example, and now we need to find out this one, A, B, B, C, C. Now we need to know how can we get this term. Okay, so this comes in the algebraic formula, one of the important algebraic formula, that is A plus B plus C whole square. What it is? Yes, A square plus B square plus C square plus 2AB plus 2BC plus 2CA. You can find AB, BC, CA. So in generally we say it as A into B, B into C, C into A. According to vectors, what we say? Yes, A into B in the sense A dot B, B into C in the sense B dot C, and as well as C dot A, and we'll take 2 as common, isn't it? Using that formula we can find this using the given data. Let us see. So we have A plus B plus C whole square, and whenever we are writing square for a vector, we compulsory take the magnitude. It is to be remembered. Okay, when we are writing square or squaring on a for any vector, we need to use the magnitude, or you can say modulus. Okay, let us say A plus B plus C whole square. What it is? A square plus B square plus C square plus 2 AB plus 2 BC plus 2 CA. Instead of multiplication in vectors we use dot. Okay, now let us use the given values. A plus B plus C, here it is A plus B plus C is 0, so I'll use this value as 0. 0 square is nothing but 0 itself. You can keep the square also, but it doesn't mean anything. Okay, let us keep this value as 0 by using this given value. Okay, is equal to A value is what? 1, so it's square as it is, plus B is also 1 and C is also 1. All the 3 values are unit vectors. Substitute in this equation, plus what we need here, we need to take 2 as common. You can see all the terms are having 2's. Let us take 2 as common. In the last term, what it remains? AB plus BC plus CA, isn't it? And that's what we require to find. Here you can see isn't it? Okay, let us see. So this is 0 as it is. 1 plus 1 plus 1. Can I write directly it as 3? 1 square is 1. Again 1 square is 1. 1 square is 1. 3. Plus 2 into, I'll write these terms as it is. AB plus BC plus CA. Right? Is it clear now? Right. Now let us bring this 3 into LHS. Plus 3 becomes minus 3 here. Again 2 AB plus BC plus CA as it is in the RHS. There is nothing change in the RHS. We'll keep it as it is. Next, what we need this bracketed value to be obtained. So let us bring this into the LHS. What it becomes? It's when we transfer into LHS, it comes down into the denominator. Yes. Okay. Therefore, can I write it as AB plus BC plus CA is equals to this minus 3 as it is, and this comes down to denominator of the LHS. It becomes minus 3. And this is our answer. So this is what he has asked to find. Isn't it? Isn't it easy? Yes, isn't it? So how to find this value and which formula to be used, that is very important. Okay, and this has been asked many times in the exams. Okay, just look into this, take it down. We'll see the next example. Okay, my dear students, so the first example is over. We'll see one more important example which is asked repeatedly in the model question papers as well as in the previous year question papers. Okay, let us see. If A, B and C are 3 vectors such that modulus of A, B and C both are given. So this is 5. Okay, and each of being orthogonal perpendicular to the sum of the other 2 vectors, then find A plus B plus C. Okay, so this is quite similar to the previous example only, but one condition is not given. So okay, and that we need to find out. Okay, the magnitudes are given compulsory. Okay, and we need to find the others in the sense he has given one condition for us. It is, and each one of the being orthogonal in the sense perpendicular in the sense the angle between them is a 90 degree. Okay, so this is like this 90 degree. So one is perpendicular to another one is horizontal, another one is vertical. So this is, we call it as a perpendicular to each other. So what is a condition to say that 2 vectors are perpendicular to each other? That is very important here. Okay, so here it is, I have written, if generally I have taken A and B, if vector A and B are said to be perpendicular or orthogonal, both meaning the same, sometimes they will say perpendicular, sometimes they will say orthogonal to each other, then what we have the condition, vector A dot vector B should be equal to 0, which means dot product of the 2 vectors are 0, then we say that the 2 vectors are perpendicular to each other. Okay, but what he has given the condition is each one of the vector is perpendicular to sum of the other 2. Each in the sense, once it will be A, one it will be B, it will be C. Each one of in the sense A, B, C separately, and A is perpendicular to sum of the other 2. Sum of the other 2 in the sense, if A is considered, other 2 will be what? B and C. And sum, he has given the sum here. You can see sum of the other 2. Sum in the sense we need to add. What we need to add? B plus C. Each one of the vector is, we consider it as A first, other 2 vectors are B and C, and their sum is B plus C. Are perpendicular in the sense dot of these 2 is equals to 0 according to the statement, isn't it? So we'll take it as a vector. And another one, B can also be one more vector. So B dot other 2 vectors are C plus A is equals to 0, and C dot A plus B is equals to 0. A, B plus the other 2. B in sense C or AC are other 2. C in the sense AB are the other 2. And these 2 conditions are perpendicular to each other. Perpendicular in the sense dot product of those 2 vectors should be equal to 0. And these 2 are the 2 different vectors, and the dot product is 0. We have three cases. Why three cases? We have three vectors here, A, B and C. Each vector is perpendicular to sum of the other two. Each in the sense A, B, C, and A is, if A is considered, B and C are other two vectors. And we need to take their sum. Here it is, their sum is equal to 0 because they are perpendicular, he said in the statement only. So these three cases, and these are the three givens. By using that, we need to consider the another problem. Okay, let us see. Okay, given A is equals to 3, B is equals to 4, and C is equals to 5. He is already mentioned. And next, well, let us see this statement. Each of one being orthogonal to the sum of the other two. Let us see. So this is nothing but what? A dot B plus C is equals to 0. This is what I have explained. Each vector is perpendicular in the sense dot is equal to 0. Sum of the other two in the sense B plus C. A is one thing, B plus C are the other two. Similarly, when we take B, the other two are C and A is equal to 0. And if we take C as the other vector, so it will be A plus B. A, B, C, B, C, A, C, A, B. They are perpendicular, that is their dot product is 0 according to the statement. Okay. So from the above, we get what we get. You can see what we have to write from this is, we'll distribute the property. Distribution in the sense, we'll apply A dot B plus as it is A dot C is equal to 0. This is like a multiplication of the two numbers only. A with B in between dot AB plus as it is A dot C, here it is equal to 0. Same in the second equation, B dot C plus B dot A is equal to 0. One more last, C dot A plus C dot B is equal to 0. From these three equations, what we can write by combining lineages? AB plus BC plus CA is equals to 0. This is another equation. Combining from these, because two terms in addition are 0, so combiningly if we write, all the three are equal with each other when they are added, and their sum will be always equals to 0 from these three. Directly you can say AB, BC, CA is equals to 0. Now again, he is asking A plus B plus C value. So how to find this one? So according to the previous problem, we need to consider the same formula. Okay. So we have A plus B plus C whole square is equals to, what is the formula? A square plus B square plus C square plus 2AB 2BC plus 2CA. You know this formula already, we have seen in the last problem, right? Now just substitute all the data and let us find the value of this. Let us see. A is what? 3 and its square as it is. Here you can see A3, B4, C5. This is 4 square as it is, and this is 5 square as it is. So we don't know the 2 times. So what we'll do again? You take 2 as common from the others. So 2 is common. What is the remaining term? A dot B plus B dot C plus C dot A. These are the 3 terms remaining in the last term, last part of the previous line, isn't it? So again, this is 9, this is 16, and 5 square is 25. And what is the value of this one? Because of equation number 1. AB, BC, CA is equals to 0. Here it is. Isn't it? From equation number 1. Now let us simplify this one. So what is the value? 16 plus 9 is 25, plus 25 is 50. So this is your, so 2 into 0, 0. 0 into dunya is 0. I said in the previously also, 2 into 0 or 0 into anything is 0. So this is what? A plus B plus C whole square. What we need? Only A plus B plus C. Just apply the root into the RHS. This will be root 50. Root 50 can I write it as 5 root 2. This is A plus B plus C. So how we have written? Because root 50 can be written as root 25 into 2. Root 25 into 2. So what is root 25? Root 25 is 5. This is a perfect square into root 2 as it is. This is how root 50 can be written as 5 root 2. So this is the simple, only this statement, how to generate this equation number 1 from the given statement is important. By using that, we have written these two and we have distributed the dot product. Then from these three, we need to write equation now, isn't it? Isn't it simple to find the value of A plus B plus C? Just look into it, we'll see the another example. Okay, my dear students, we'll see one more important example on vector algebra for 3 marks. Okay, that is, if vector A is equals to 2i plus 2j plus 3k and vector B is equals to minus I plus 2j plus k and C is equals to 3i plus j, such that A plus lambda B is perpendicular to vector C. So this is vector C, okay. Then find the value of lambda. We need to find the value of lambda or lambda, you can say. So this is the lambda to be obtained. So we need to find the value of lambda. Lambda is any constant value, okay. And here also we need to use this node point which we have used in the previous problem, that is perpendicularity of the two vectors, because he said A plus lambda B is perpendicular to vector C, which means the dot product of these two vectors is equals to 0, okay. Considering A is this whole term and B is this term, because these are the two vectors are perpendicular what he has given. Okay, let us see. So these three are given already. First, what we need to find out? We need to find out A plus lambda B first. Let us see. Vector A plus lambda B, in the sense vector A is this one. We'll take 2i plus 2j plus 3k plus a lambda as it is. Okay, and B is this one, minus I plus 2j plus k, isn't it? So A lambda constant as it is and vector B in multiplication. Let us see. So this is 2i plus 2j plus 3k. Now I'll multiply lambda here. So this is minus lambda into I, lambda here 2 lambda j, right? Again lambda with k plus lambda k. This is simple, just multiplying this lambda into I, j and k. Okay. Now what we need to do, these are the two vectors should be added. So how to add the two vectors? This is very simple. What you need to do is, you need to add the I term with I, j with j and k with k. Okay, let us see. So this is your I with I and this is your j with j and the last one k with k. You need to add them. So 2i minus lambda day. So 2 and lambda will not be added because one is variable, another one is constant. We keep it as it is. 2 minus lambda. So what we write? 2 minus lambda into I, because those two cannot be added or subtracted. Okay. Next, j with j, 2j plus 2 lambda j. What we write? 2 plus 2 lambda into j. Again we need to add them. Again we have 2 lambda plus 2. 2 is a constant, 2 lambda is a variable. We need to keep them as it is. Then k with k. Here it is 3 plus lambda into k. Isn't it? I with I here, j with j, k with k. If there are numbers, then we would have added. If it is a 2i plus 3i or minus 3i, 2 minus 3 is minus 1, I would have written minus I here. So numbers will be added or subtracted with each other, not the numbers with the variables. So that is why we kept lambda and 2, lambda and 3 as it is. Okay, let us see. So this is your a plus lambda b. Okay, since a plus lambda b and c are perpendicular, this is what he has given. Perpendicular in a sense, that is a plus lambda b dot c is equals to 0. According to this statement, perpendicularity, if a and b are perpendicular to each other, then what is the condition? A dot b is equals to 0. Here these two vectors are perpendicular, so their dot product is equals to 0. Now I'll use a plus lambda b vector and c vector and will operate the dot property, dot product, scalar dot product. Let us see how to operate. So a plus lambda b is this one. We'll keep it as it is. So what it is? 2 minus lambda into I plus 2 plus 2 lambda into j plus 3 plus lambda into k. Dot product vector c is what? Here it is. So directly it is 3i plus j. If nothing is there, you can take it as 0k. If nothing is there, k is missing here. So you can take it as simply 0k to easy simplification so that you can understand things easily. Is equals to 0. This is vector a plus lambda b, this is vector c. Now how to operate or how to find the dot product of two vectors, that is a dot b. So this is also very simple. What we need to do is just look at the coefficients of I, j, k, k. So here it is I coefficient. Okay. Now this is your j coefficient and this is your k coefficient. I'll double mark it. Okay, right? Now these two has to be understood. Okay. Just multiply the coefficients of I with I, j with j and k with k. So here the I coefficient is 2 minus lambda. 2 minus lambda into I coefficient of second vector. I coefficient is 3 into 3. You multiply I coefficients, j and k. And one important thing what you need to remember is in between you need to use what is the multiplied sign. Okay, let us see. What is j? 2 plus 2 lambda into j coefficient. If anything is not there, so it will be 1j. So plus 2 into 2 lambda, I'll take plus in between. 2 plus 2 lambda into 1. This is 2 plus 2 lambda and this is 1. Okay. Again in between plus, k coefficient is 3 plus lambda and k coefficient is 0. Is it simple? Multiplying the I with I, j with j, k with k by adding in between. Simple. I with I, j with j, k with k, in between plus sign. Here you can see. Isn't it? Just simplify. So what it becomes? 2 into 3 is 6 minus 3 lambda. Just multiplication. Plus 2 into lambda is 2 plus 2 lambda because into 1 remains the same thing. Plus 0 into anything is 0. Let us simplify this. Now look into the lambda values. This is minus 3 lambda plus 2 lambda. Minus 3 plus 2 is minus lambda. And what are the constants? 6 plus 2, 8. Therefore, lambda is equals to 8. Simple. This is very simple. So we have learned two things here. One is how to use the condition of a dot b is equals to 0, perpendicularity, one thing. Second, addition of two vectors and dot product of two vectors also. Addition is I will be added with I coefficient, j is added with j, k with k. Now dot product in the sense we need to multiply. Just I dot is there. How to multiply in the sense we need to multiply the coefficients of I with I with I, j with j and k with k, in between plus sign. This is I coefficient plus j coefficient plus k coefficients. Then simplify, will get a finite value. Therefore lambda is equals to 8. Isn't it simple? Okay. I hope you're understanding this. So clearly observe this and take a screenshot or write it down. Welcome back, my dear students. We'll see one more example on this, and please try to understand that just vector algebra is a matter of mainly the formulas and some properties, as well as only two operations, major two operations. So basically there are four. One is addition of the vectors, subtraction of the vectors, a dot product of the scalars, and cross product. Only four. On these four only the whole vector chapters are dependent, and few formulas. Likewise, the conditions of perpendicularity, find the area of triangle, area of parallelogram. Okay, then projection of vector A on B, B on A. Only very simple. Okay, these are the only 6 to 7 formulas and 4 operations. The whole chapter will be completed in this. Just practice these things. Definitely you will score full in on this chapter. Okay, let us see one more important. So find a unit vector perpendicular to each vector A plus B and A minus B, where A, vector A and vector B are given. Okay, and he is asking to find a unit vector. Okay, so this is the formula to find a unit vector. I have taken vector A here. It is read as A cap. This is called as cap. A cap is equals to vector A divided by modulus of vector A, or magnitude of vector A. So to find unit vector, we need only one vector. Okay, and what he has given? He has given two vectors, and we need to convert into one vector to find this, isn't it? And before that, he hasn't just asked the unit vector for these two only. He has asked vectors for A plus B and A minus B, which means we need to find out first A plus B, then A minus B, then operate to convert into single vector like this to find. Okay, let us see. First, let us find A plus B. A is what? 3i plus 2j plus 2k, plus B is what? I plus 2j minus 2k. Just what you need to do is add I with I, j with j, k with k. 3 plus 1, 4i. Simple thing. Okay. 2j plus 2j. 2 plus 2, 4. That is 4j. 2k minus 2k plus 0k. This is as simple as that. So this is your A plus B. Right. Next, what we need? A minus B. Let us say A minus B is equals to, again I'll keep A vector 3i plus 2j plus 2k minus vector B as same thing again, I plus 2j minus 2k. As of the above, just subtract I with I, j with j, k with k. Let us see 3i minus I. The minus is applied to first term, second term, third term as well. You know this, minus I. 3i minus I. 3i minus I is 2i, isn't it? Let us see 2j minus 2j plus 2j minus 2j. 2 minus 2, 0. Last one. 2k minus of minus plus 2k. 2 plus 2, 4. 4k. This is your A minus B. This is done now. Okay. What he has asked to prove, we have done the same thing. And now we need to convert these two vectors into single vector, because unit vector is to be obtained by using one vector only. So how to find or how to convert 2 into one vector is by using the cross product of two vectors. As I said, you need to understand addition, subtraction, dot product of two vectors and cross product of two vectors. That is very important. And we have seen in the same problem addition, subtraction. We'll see the fourth property also, that is cross product of the two vectors. Let us see. So cross product of what two vectors? Which two vectors? A plus b and a minus b. Okay. I'll take the vector cross product as C. A plus b cross A minus b. So this is a symbol to note the cross product of two vectors. Dot product is a single dot, simple dot. Okay. So how to find this one is you need to take a determinant, and first row is your I, J, K. This is the format to operate A cross B or cross product of any two vectors. And we have three rows here. First row will be your compulsory I, J, K. Second row values are this one, first vector. First vectors are A plus B. A plus B, here it is. What you need to take here is I coefficient, J coefficient and K coefficient. So I coefficient is 4, I'll write it as 4. J coefficient is 4, again I'll write it as 4. K coefficient is 0. You write it as 0. With sign, whether it is a plus 4 or minus 4. Let us see. Okay. And what is the last row will be the second vector, that is A minus B. Here it is A minus B. Again coefficient, I coefficient is 2, J coefficient is 0, K coefficient is 4. Isn't it simple? ठीक है, ये समझ में आ रहा है आपको सब लोगों को? जो भी दो वेक्टर के क्रॉस प्रोडक्ट ऐसा सिंबल से नोट करते हैं, उसके बाद फर्स्ट रो का वैल्यू आई जे के कंपलसरी है, उसके बाद सेकेंड रो का वैल्यू ये फर्स्ट वेक्टर जो भी है ना क्रॉस प्रोडक्ट का, इसका आई जे के कोएफिशिएंट विद साइन, पॉजिटिव रहे तो पॉजिटिव ले लो, नेगेटिव रहे तो नेगेटिव, एंड दिस इज योर सेकेंड. नाउ वेरी सिंपल वे एक्सपेंडिंग द डिटरमिनेंट. And you know already, if you have seen my previous videos on determinants, you will compulsory expand this very easily. How? Plus, minus, plus. Okay. If you didn't watch it, please go and watch the previous videos. So you'll come to know how to find the determinant of a 3 cross 3 matrix. So how to find? First, you need to take I as it is, and you need to close its row and its column. You know this trick, right? So which one you are doing? You can close the row, column and its row. Here it is. You'll remain with you'll remain with 4 element. You can see left minus of right, left, your left to your left. Left is 4 into 4, 16. In between minus compulsory. This is a form. 0 into 0, 0. Is it okay now? Next, minus j. Minus j. You need to consider this sign, minus j. Again, close its row and its column. And these are the 4 elements available for it. Again, left minus of right. 4, 4 is 16. 2 into 0. 16 formula minus and 2 into 0. Is it clear now? This is very simple. Next, plus k. Plus k. Again, close its column and its row. These are the 4 elements. Left minus of right. Left 4 into 0 is 0. Minus 4 to 8. Isn't it? Let us simplify. This is 16i minus 16j minus 8k. This is your vector C. Now, find the unit vector of this C. We have converted 2 vectors into single vector. Okay. Now let us find the vector C. So that is C cap is equals to vector C by its magnitude. Vector C is the same, 16i minus 16j minus 8k divided by. Now, how to find the modulus? This problem is a combination of multiple things to learn. This is very important problem, because you are learning addition, subtraction, cross product, as well as unit vector, as well as the modulus. This is called as magnitude or modulus of a vector. Okay, so how to find this is also very simple formula. What you need to take the square root, okay, and take the, this is your vector C, right? This is I, J, K. You need to take the I, J, K coefficients and square it. So this is 16 square, in between plus compulsory. J coefficient is minus 16 square and plus compulsory, and K coefficient is minus 6. Okay. Coefficients of I square plus J square with sign plus K square, isn't it? So I'll take 8 as common in the numerator, that is 2I minus 2J minus K divided by. So what it will be? What is 16 square? 15 is 225 and this is 256 plus 256 plus 64. 8 into 2I minus 2J minus K divided by square root of. Now write it down, what you will get. Please calculate that. So what did you get? So this is 576, 256 plus 256 plus 64. And this is a perfect square, that is, I'll write 8 of 2I minus 2J minus K divided by, so root 576 is a perfect square of 24, and you can cancel this. 8 1s are 8 3s are, and this is your vector A cap is equals to, I'll divide 2 by 3I minus 2 by 3J minus 1 by 3K. And I have separately divided here 2 by 3, 2 by 3, 1 by 3, isn't it? So this is some of the important examples on vectors, and in the next class we'll see some more important examples are there, expected questions to be asked in the board examination of class 12 UC second year. Okay, so I hope all of you understood this. So please go through with the previous videos and from starting to end to understand the concepts as well as the other questions also, isn't it? So if you understood this, please like, share and subscribe, and share with your friends and classmates so that they can also watch these important examples and can clear their concepts, can easily score good marks in board exams. Okay, see you again in the next class. Thank you.